queries in Microsoft Sentinel using Custo. You need to be able to write Custo query language, or better said, KQL statements, to query log data so that detections, analysis, and reporting in Microsoft Sentinel can be done. We will focus on the most used operators and show a few examples of KQL statements that will showcase security-related table queries. We will first discuss the construct of KQL statements for Microsoft Sentinel. How does basic KQL statement structure provide the foundation to build more complex statements? Well, that's a question we will answer. To begin with, and read along on the slide, a KQL query is a read-only request to process data and return results. The request is stated in plain text, using a data flow model designed to make the syntax easy to read, write, and automate. Okay, so let's break this all down. The query consists of a sequence of query statements. At least one statement is a tabular expression statement that produces data arranged in a table-like mesh of columns and rows. The query's tabular expression statements produce the results of the query. The tabular expression statement syntax has tabular data flow from one tabular query operator to another, starting with the data source and then flowing through a set of data transformation operators bound together through the use of the pipe delimiter. Now, let's use some statements. Let statements bind names to expressions. For the rest of the scope where the let statement appears, the name refers to its bound value. Let statements improve modularity and reuse since they allow you to break a potentially complex expression into multiple parts. Each part is bound to a name through the let statement, and together they compose the whole. Let statements allow for the creation of user-defined functions and views. The views are expressions whose results look like a new table. Let statements allow for the creation of variables to be used in later statements, and let statements allow for the creation of dynamic tables or lists. The search operator provides a multi-table, multi-column search experience. Although the search operator is easy to use, when compared to the where operator, using KQL search is inefficient compared to using the where operator, which we will discuss next. Even with this inefficiency, you can use search to find data when unsure which table or column to filter. The first statement will search for error across all tables, and as can be seen on the slide, the second statement will search for error in tables security event, security alert, and tables starting with A. Then, the where operator. The where operator filters a table to the subset of rows that satisfy a predicate. See a few of examples and results on the slides. Then, the extend operator will create calculated columns and append the new columns to the result set. This KQL example uses the extend operator to create a new column, start dir containing the directory a process was started in. The start dir column is a calculated column containing the results of a substring function. Use the order by operator. You can sort the rows of the input table by one or more columns. The order by operator can utilize any column or multiple columns by using a comma separator. And very important to know here is that each column can be descending or ascending. The project operators control what columns to include, add, remove, or rename in the result set of a statement. There are multiple types of project operators. The table on the right is a list of the variations. See the descriptions of the operator. With project, you select the columns to include, rename, or drop and insert new computed columns. With project rename, you select the columns to rename in the resulting output. And with project reorder, you set the column order in the resulting output. Custo Query Language, KQL, is the query language used to perform analysis on data to create analytics, workbooks, and perform hunting in Microsoft Sentinel. We will now analyze query resulting using KQL and discuss how to summarize and visualize data with a KQL statement, which provides a foundation to build detections in Microsoft Sentinel. We will discuss using the summarize operator first. The count operator with its variations will create a new column with the calculated result for the specified fields. The statement at the top left returns a count of security event rows, and the count is grouped by process and computer. Because of the by clause, the result set will contain 3 columns: process, computer, count. The second statement on the left of the slide is a rule to detect MFA failures across multiple applications for the same account. The where operator for result description will filter the result set for results including MFA. Next, you can see that the statement summarize produces a distinct count of application names and group by user and IP address. Finally, there's a check against a variable created threshold to see if the number exceeds the allowed amount. And then you can use the render operator to create visualizations. The supported visualizations are area charts, bar charts, column charts, pie charts, scatter charts, and time charts. You can also use the summarize operator to create time series. The bin function, as we can see on the slide on the left, rounds values down to an integer multiple of the given bin size. If you have a scattered set of values, the values are grouped into a smaller set of specific values. Combining the generated time series and piped to a render operator with a type of time chart provides a time series visualization. We will now learn how to build multi-table statements using KQL. To query log data, you use a custom query language. Often a result set from a KQL statement needs to be combined or joined with another result set. This is where the union operator comes in, because you can use the union operator to combine 2 result sets. The union operator takes 2 or more tables and returns the rows of all of them. Understanding how results are passed and impacted with the piped character is essential. Based on the time window set in the query window, query 1 will return all rows of security event and all rows of sign-in logs. Query 2 will return 1 row and column, which is the count of all rows of security event and all rows of sign-in logs. Query 3 will return all rows of security event and 1 row for sign-in logs. Run each query separately to see the results. The join operator merges the rows of 2 tables to form a new table by matching the specified columns values from each table. The first table specified in a join is considered the left table. The table after the join keyword is the right table. The columns from the tables are designated, the left column and the right column, to distinguish which table's columns you're referencing. Let's now work with string data using custom query language to manipulate string data ingested from log sources. Often fields in a table store structured and unstructured string data. You write KQL statements to extract and manipulate data stored in these fields. A typical scenario is a key value pair stored in a field and you need to query the specific value of a key. That's why it is important to understand how to work with fields containing structured and unstructured string data with a KQL statement. Security log data is often contained in unstructured string fields and requires parsing to extract data. There are multiple ways of pulling information from string fields in KQL. The 2 primary operators used are extract and parse. Extract gets a match for a regular expression from a text string. You may optionally convert the extracted substring to the indicated type. The example on the slide uses the extract function to pull out the account name from the account field of the security event table. Parse evaluates a string expression and parses its value into one or more calculated columns. The computed columns will have nulls for unsuccessfully parsed strings. Just to be clear, when you extract data from structured string data, string fields may also contain structured data like JSON or key value pairs. KQL provides easy access to these values for further analysis. We will now move on to the demo for Model 4, create queries for Microsoft Sentinel using custom query language. Go to aka.ms/la-demo, and this is the website that you will see. And we can explore the available tables listed in the tab on the left side on the screen. So we can see here Azure Directory Health Check. We can also see Azure Monto for VMs, Azure Resources, and so on. And in the query area, which is right here, we can actually enter queries and select the Run button. And we will do that right now. So we'll go for security event. Let's just type it in, and we can actually run this. It will take some time. And actually, at this very moment, security events are being searched for. And there you go, showing the first 30,000 results. That's quite a lot, it sounds like, but it's true. We have quite some results. The first 30,000 are now shown. We can take a look at all the records, and we can actually expand the information for the row. Let's do that right now. And here we can see quite some information. We can see the tenant ID, the time generated UTC time, and the source system, account, account type, computer, and so on. And we can scroll down and you can see quite some information for this specific security event. Now let's also run some basic KQL statements. Now we will build basic KQL statements, and I'm going to use a statement that demonstrates the use of the let statement to declare variables. In the query window, right here again, we can enter a statement and select Run again. Let me copy paste that right here, and there we have it, and we can now click Run. And it is running the query again. Takes some time, as we can see. And there we have it. And as we can see, the event ID is 4688. It's a time span of 7 days, and there's a lot of information added, and we can see quite some events that took place. Now, we can also use another statement that will demonstrate searching across all tables and columns for records within the query time range display in the query window. Let's now also create visualizations in KQL with the render operator. We will now generate visualizations with KQL statements. Now, we're going to use a statement that demonstrates the render function visualizing results with a bar chart. Let's use a statement and, of course, run the statement. There you go. And we are going to create a visualization. There you have it. The bar chart appeared within seconds, less than seconds. This concludes part 1 of our session. Let's recap all the content that you have seen so far. We discussed mitigating threats using Microsoft 365 Defender, Microsoft Defender for Endpoint, and Microsoft Defender for Cloud. Plus, we explained creating queries for Microsoft Sentinel using KQL. Thank you for your attendance so far, and we look forward to seeing you next time for part 2 of this Microsoft Security Virtual Training Days. Defend against threats and secure cloud environments.